Hi, welcome to Equa Mode. Want to solve an equation? This is the way to do it. I wonder if you realised Equa stands for equation. But what is an equation? It comes from the word equating, or putting two things equal. And back in algebra, we thought of a number, tripled it, so something like that, added 2, and maybe the answer was 8. That was one of the first mathematical sentences you saw, and that's called an equation, and we want to try and solve these equations and find the missing number, and here we're letting x stand for that. So we're moving on from this sort of equation here in this work because we're moving into some of the year 10 harder examples now. And so we'll leave that and have a look at what sort of equations we can solve at a higher level. So what I'd like you to do is to scroll to Equa using this button. You can see Equa has been highlighted there, and then hit execute. Or for the first time, can you see we've got a letter there for that icon? So to choose that, we'll actually have to choose alpha for the alphabet, and then this button here to isolate the A. So that's something later on with calculators you might need to do, choosing letters down there. But this one then is highlighted, and if you choose that, you'll go straight into Equa Mode. So I'd like you to do that now. Here we are. A number of options are shown here. What sort of equation do we want to solve? Well, let's look at the first one. The first one says F1, or the simultaneous option here. Simultaneous means we want to solve two equations at the same time. What would the equations look like if we wanted to do that? Well, let's have a look at a couple of equations. Let's say I think of a number, double it, add 3 times another number, and the answer is 8. What if then I also say I use the same first number, add twice that second number, and the answer is 5. Getting difficult now because I need to find a first number and a second number so that both of these things are true. Let's have a look. It says twice the first number, 3 times the second must be 8. Also, 1, we don't write the 1, do we? Usually, 1 lot of the first number plus 2 lots of the second number equal 5. What on earth were the numbers? So let's see if we can get the calculator to do that for us. So simultaneous up here, it says it's F1. So let's hit F1 now and have a look. Now looking at this, we can say first of all that there's no data in the memory. What that means is, just reminding you might have used the calculator before and left equations in there, but it's saying here that you haven't. Even if on your calculator there is data in the memory, we can overwrite that. So that's not a problem. It's asking us the question, number of unknowns. Now, how many unknowns do we have? Well, writing those equations again, here we said that this was 1 and this is the other. So can you see that there are 2 missing numbers, x and y? So we've got 2 unknowns in our problem here. Later on in maths, beyond year 10, you might have a situation where we have equations like this. Obviously there are 3 missing numbers here, an x, a y and a z. Our letters are standing for those missing numbers, so that would be 3 unknowns. But for our work this year, the number of unknowns would be 2, x and y. So let's choose 2 by hitting F1 here. So I'd like you to do that now. And here we have a window asking us to put our equations in to the 2 rows there. Let's have a look at the form right at the top here. It says we're allowed to put in an AN. That means some number in front of x which could vary from equation to equation, and then a number of lots of y, and then the answer over on the right. So here we're going to enter our first equation here in our first row, bit by bit in a minute, and then this one here, x plus 2y equals 5. So you can see the first entry here highlighted is for the number in front of x in the first equation. So here it is. This dude needs to be put in now. So what I'd like you to do is to hit 2 on the keyboard and then execute, and you'll come to this. You'll notice that the 2 is nicely entered and the highlight's gone to the next position, the number of y's. So what I'd like you to do now is to enter in that first row. So we've started the process now. We've entered that one, and then this one in the second row. So if you do that now by, what will we do? Well, our next number to put in is 3 and hit execute, and then the highlight will move across here and we put in 8, and then remember there's a 1 there, we don't write it, and hit execute, and then 2 and hit execute, and then 5 and hit execute, and we should have all of those spots filled and our equations entered. So I'd like you to do that now. And do you have this? We can see we've got the equations nicely entered here. Yeah, the first one and the second one there. And now what we need to do is to see if the calculator can find an x and a y to satisfy both those equations. So over here there's solve, so you can hit F1 or you can just hit execute. That's an option, and I'd like you to do that now. And here we see the answers displayed. Here's the x answer, and because it's highlighted, it's also repeated down here. And here's the y answer. So the calculator is saying the numbers you thought of were x is 1 and y is 2. Let's just check that out now. In the first equation, 2x plus 3y equals 8. Let's check it. 2 times 1 plus 3 times 2, yes, that does give 8, that's good. And then in the second equation, x plus 2y equals 5. If x was 1, that'd be 1 plus 2 times 2, yes, that equals 5, that's correct. So that's very good. If we now want to have a look at some other equations, let's go back, and so I'd like you to hit execute now, and we'll go back to this window. So we've looked at simultaneous. What's this next dude in here? F2, polynomial. Now I don't know whether you realise poly in English means many, usually from the Latin, and nomial is something to do with number. So we've got many numbers in this equation. What does that mean? Well, in this case it means many powers in an equation. Have you ever seen many powers in a mathematical expression or equation? Do you remember? Wasn't it back in graph mode part 2 where we looked at this function to look at its graph, x squared plus 5x plus 6. So that does have a few powers in there. So we might want to use this one. Can you see that's x to the 1 and this is x squared? So this is a simple polynomial, more than 1 power of the variable or unknown there. And if you remember, we wanted to find where the graph of this function cut the x-axis, if you remember, back in graph mode part 2. And we used gsolve, shift F5, to find that. Now there's another way here we could do that, because we said all along the x-axis y is 0. So let's put y as 0 and see if we can find the x's of these two spots here using a different approach, not using gsolve. So we want to now solve this equation. So let's see if we can choose polynomial now, whereas at polys here, let's choose by hitting F2. And again, we are told that data exists in the memory. That doesn't matter. We can overwrite that. What degree have we got? A degree. We haven't had that before. A degree equals the highest power in the equation. So what was our highest power? Let's look at it, writing it left to right this time. We want this expression to be 0. What's our highest power? There it is there. So our degree, and that's all you'll be doing up to the end of year 10. And so let's choose that by hitting F1. And so if you do that now, there we have a similar entry from before, asking us for the number of x squareds, number of x's, and the constant. So let's have a look at what we will do. So let's write our equation out again in the same way. Okay, so we can see again, number in front of x squared is not written, it's understood to be 1. So we'll need to put in the first spot there 1, and then a 5, and then a 6 here. Okay, so you can see the calculator requires the equation to be written always equal to 0. Okay, so we are set up nicely to do this. So let's have a look now. So what we need to do is to enter 1 from the keypad and then execute, and then 5 and execute, and then 6 and execute. And if you hit that twice right at the end, then you'll have this window here. So it will give you our equation. Yes, this is right. 1x squared plus 5x plus 6, and always equals 0 in this mode. So we've got that, and let's hit execute again, or you can hit F1 to solve it. If you hit execute again, you will get the solution nicely listed. Here we have it. The first value, x1, is -2, and x2 is -3. So it's giving us two possible answers to our problem. What x values make our function equal to 0? So x is -2 or x is -3. And we could put those numbers back in here in the x positions and check it out. And if you remember back to graph mode part 2, what we were saying is these are the values here, -3 and -2, where the graph of the function cuts the x-axis, because along the x-axis that's when y is 0. So that's good. If you hit execute again now, you can see it highlights the second one, which is -3. What I'd like you to do now is to hit execute and return to this window. Now there is a third option down here called solver. This is quite a handy method of solving a range of equations, and it's not something you'll need up to the end of year 10, but something you might look at a bit later on. So I hope you have enjoyed looking at these equations. It raises some interesting questions in algebra as well, doesn't it? So algebra has to keep up to use this. Anyway, it's time to go. I hope you have fun solving equations, and I hope to catch you later, but cheers for now.